In 1973, Rupert Sheldrake sat in his Cambridge lab staring at a bean plant. It was doing something that shouldn't be possible, according to everything he knew about biochemistry.
The guy was called Rupert Sheldrake.
Yes, why?
That's the kind of name that's gonna cost you a fortune in lunch money.
Yeah, I don't think there was a lot of bullying going on at Cambridge.
Oh, wake up, human. Wedgies are universal. I bet even Stephen Hawking had to eat his own tighty-whities from time to time. And he sat on those things all day.
Anyway, bean plants are like vines. They can't stand on their own. They need a structure to grow around, a wall, a fence, a tree. He was growing plants using pots and small wooden poles for support. Same method every time. The plant sprouts, grows toward the pole, and starts climbing. But this particular bean plant was doing something very strange. It was growing toward a pole that wasn't there yet. It was growing to where the pole would be in the future. Now, Sheldrake was a serious scientist. Cambridge Fellowship, Harvard, PhD in biochemistry, director of studies at age 31. His research on plant hormones is still in textbooks today. But this bean plant was bothering him. Plants don't have eyes. They don't have nervous systems. The support pole wouldn't be installed for another 2 days, yet the bean was already changing its growth pattern, already preparing to climb something that didn't exist yet. He'd seen this before, thousands of times. Every biologist had. They just didn't talk about it. DNA doesn't actually contain the blueprint for what an organism becomes. An acorn has the same DNA in every cell, but those cells grow into roots or leaves, branches. They organize themselves into a tree, and nobody can really explain how they know to do that. Think of DNA like Lego bricks. A Star Wars set and a castle set use exactly the same pieces. The only difference is the final shape. A fruit fly, a banana, even a human being share most of the same DNA, but they develop into completely different organisms. The final shape isn't in the DNA. Something else is guiding the process. One night, walking home along the River Cam, Sheldrake had a moment of clarity. Maybe nature has a memory. When any system organizes itself, a crystal forming, a plant growing, an animal learning, it creates what Sheldrake would call a morphic field, a memory in nature. A similar system can resonate with that field and access that memory, meaning a bird learning to pierce the foil, crystals learning to form. And the more that memory is accessed, the stronger it gets. And it influences everything that comes after, across space and time. No physical connection required, because that memory is now part of nature, all of nature, everywhere, forever. In 1974, Sheldrake moved to India to work at an agricultural institute. That was his day job. He spent his nights at a monastery, and for 18 months, between prayers and meditation, he wrote a book proposing that the universe has memory. He called it A New Science of Life. He published it in 1981. The most important science journal in the world responded by calling for his book to be burned. The theory of Morphic Resonance cost Sheldrake his career, and a few years later, it almost cost him his life.